Welcome back everyone to our new channel Catalyst for IIT JEE for the preparation of IIT JEE exam as well as NEET exam. Along with that, with this lecture series, you can also prepare for your board exams. I am Deepthi Girl from IIT Madras and this is my second lecture on IUPAC Nomenclature. In my previous lecture, I have taught you the basic what is hydrocarbon, versatile nature of carbon and all the rules for the nomenclature of saturated hydrocarbon. In my second lecture, or else you can say in this lecture, I will teach you all the rules for the nomenclature of unsaturated hydrocarbons and rules for the nomenclature of hydrocarbon with functional group in it. While in my third lecture, I will solve some previous year questions. So let us start this lecture by asking a very simple question: what is unsaturated hydrocarbons? Although I have already taught you very precisely the difference between saturated and unsaturated hydrocarbon, and in this lecture I will brief you what is unsaturated hydrocarbon. So all the hydrocarbon with double covalent bond or triple covalent bond, they can be classified as your unsaturated hydrocarbon. So these double and triple covalent bond can be classified as multiple bond together, and it's a combination of your sigma bond and pi bonds. So how you will calculate how many pi bonds are present in your molecular formula, or as well as you can say how many pi bonds are present in your structure. So you can calculate by calculating the degree of unsaturation. So it actually is a calculation used to measure the number of pi bonds in your unsaturated hydrocarbon. Or simply you can say, for your saturated hydrocarbon, degree of unsaturation will always be equal to 0, while there is some value that should be an integer, as bond cannot be a fractional unit. So it should be an integer and there will always be a value for unsaturated hydrocarbons. So this is your formula for the calculation of degree of unsaturation, where C corresponds to number of carbon present in your molecular formula, while N corresponds to nitrogen, X means all the halides if present in your molecular formula, H corresponds to hydrogen. For example, this is your molecular formula C2H4, and according to this formula, number of carbon in this molecular formula is 2, while number of hydrogen present is equal to 4. So if you calculate and put all these value in this formula, you will find that degree of unsaturation is equal to 1. So it means that both the carbon in this formula is connected by sigma bond as well as your pi bonds. So number of pi bonds is equal to 1. So this is the structure for this molecular formula. So with this degree of unsaturation, you can calculate how many pi bonds is present in your molecular formula, and you can also draw the corresponding structures, or else it is also possible that for a certain molecular formula there are more than one structure in it. So let us start. What's the rule for the nomenclature of all unsaturated hydrocarbon? So this is your rule number 1. The parent chain is numbered so that the multiple bond has the lowest number. It means in your unsaturated hydrocarbon, you have to start naming in that order so that all the double bond and triple bond should get the lowest possible number. If there are any other substituent such as your alkyl group or halogen substituent, you should take as the lower priority and you should give priority to your double bond and triple bond. So you can also understand this rule by this example. So there are two ways to select your parent chain. You can choose parent chain in this way also, and you can also start numbering your parent chain from this direction also. So but according to this rule, you have to give the lowest possible number to your double bond. So you have to start numbering your parent chain from this direction, because on your first there is a double bond, but if you start numbering from this direction, the lowest possible number given to your double bond will be 1, 2, 3, 3rd, 4, 5, 5th position. So which is obviously greater than your 1 and 3. So this is the correct way of numbering your parent chain. So this will be your IUPAC name because there is a methyl substituent on 5th position. So 5-methyl, hex means number of carbon in your parent chain is equal to 6. So 6 means your hex, and you should always number on which carbon number your double bond or triple bond is present. So both double bond are present on your first position and third position. So that's why you have written your 1 and 3. So the number of alkene, or else you can say double bond, is 2 in this molecular formula or in this molecular structure. So there will be a di prefix before this E. So the whole IUPAC name is 5-methyl hex 1,3-diene. Now the next question arises is how to number your parent chain if your double bond is present on one end and your triple bond is present on the other end. So how will you number your parent chain is dependent on your rule number 2nd, which says that if both double bond and triple bond are present, you have to give the lowest possible number to your double bond rather than giving lowest possible number to your triple bond. And alphabetically E comes before Y, so you have to give priority to E rather than giving to ion. In your IUPAC you have to write E first, then ion. So you can also understand this rule number 2 by taking this example. In this unsaturated hydrocarbon, double bond is present in this end and triple bond is present on this end. So there are two ways to number this parent chain, from this end as well as from this end. So according to rule number 2, you have to give the lowest possible number to your double bond. So you will start numbering from this edge, 1, 2, 3, 4 and 5 and 6. Now on 2nd and 3rd, methyl substituents are present. So your IUPAC name for this unsaturated hydrocarbon is 2,3-dimethyl, as on 2nd and 3rd position methyl substituents are present, and hex means number of carbon in your parent chain are 6. 1 means at your first position double bond is present, while on 5th position your ion is present, means triple bond is present. So you would wonder that where this E has gone. So according to rules, you have to eliminate this E while writing this whole name. So your collective IUPAC name is 2,3-dimethyl hex 1E and 5-ion. In this example, there is only one parent chain possible. Sometimes it happens that there are 2 or 3 parent chain are possible. So it is very difficult to understand or to select which should be the correct parent chain. So rule number 3 says that for your branched hydrocarbon or branched unsaturated hydrocarbon, the parent chain is the longest chain that should have maximum number of double or triple bond. If there are 2 or more chains competing for the selection, the choice goes in this order. Parent chain should be the chain with the greatest number of carbon atom. For example, you can also say that if your substituent has double bond or triple bond in it, so according to rule number 1, your parent chain should have all the double bond and triple bond in it. But sometimes it is not possible to take all the double bond and triple bond in a single parent chain. So that's why sometimes it happens that 2-3 parent chain can be possible, and the selection goes in the order the chain with the greatest number of carbon atoms. Sometimes it also happens that 2 or 3 has following this rule simultaneously, then you can jump on the second choice If the number of carbon atom being equal, then the chain containing the maximum number of double bonds. So you can take this example to clearly understand rule number 3. So in this example, you can see that if you choose this parent chain as your parent chain, so this double bond has been left. So clearly there has been this way also to choose as your parent chain, but the number of carbons present in this parent chain are 1, 2, 3, 4 and 5. While if you choose this as your parent chain, number of carbon present in your this parent chain are 6. So you can choose between these two according to rule number 1. The chain with the greatest number of carbon atoms should be considered as your parent chain. So this is your parent chain and this is your substituent, and this substituent name is your vinyl, and the whole IUPAC name is 3-vinyl as this is present on third carbon. Hex means the number of carbon in your parent chain are 6, and on your 1 and 3rd position your ene is present, means your double bond is present. So the whole IUPAC name is 3-vinyl hex 1,3-diene. So these are the rules for the nomenclature of your unsaturated hydrocarbons. With all these 3 rules, you can name any unsaturated hydrocarbon which contain your double bond or triple bond in it, or more than 1 or 2 or 3 double bond and 3 triple bond and so on. So now jump on the rules for the nomenclature of your hydrocarbons which has functional group in it. So first of all, you have to understand what is your functional group. Functional groups are the moieties and the substituent that are attached to the hydrocarbons. Hydrocarbon, they can be your unsaturated hydrocarbon as well as your saturated hydrocarbon, and these functional groups are responsible for molecules, for characteristics, chemical reactions. So these are the examples of your functional groups, and these are the suffix used while naming hydrocarbons which has functional group in it, and these are the prefix used for the nomenclature of your functional groups. And this is the priority order. If in a particular hydrocarbon, if more than one functional group is present, then you have to select in this priority order. For example, if this carboxylic acid and aldehyde both are present in a same hydrocarbon, then you have to give priority to the carboxylic acid, not to the aldehyde. So this is the priority order set for the nomenclature of your functional groups. At this point, we know what the functional group does and what the function group is. So we will start the rules for the nomenclature of all the hydrocarbon, whether it can be a saturated as well as unsaturated hydrocarbons with functional group in it. And we will study first functional group, which is your halogen, and the general formula or say general representation of your halogen functional group is given by X, and X can be your fluorine, chlorine, bromine and iodine, and general name which is given for your saturated hydrocarbon with halogen functional group in it will be your alkyl halide. Okay, now these are the classes. If fluorine is present in your hydrocarbon, then you have to add fluoro. If chlorine is present, then chloro. If bromine is present, then bromo. If iodine is present, then iodine. Let us take this example. Now, first of all, you have to understand how to select or which one is your parent chain. First of all, we know that parent chain should contain all the substituent and your functional group, and according to rule, you have to give the least possible number to your functional group as well as substituent. So there are basically two ways to identify, or else you can say to start numbering to your parent chain, which is from this side to this side as well as from this side to this side. If you start from this side, 1, 2, 3, 4 and 5. substituent and functional group will be given as second and third position. But if you start from this end, 1, 2, 3, 4 and 5, this fluorine will be at third position and the substituent will be at fourth position. So basically third and second is much better, or else you can say the lowest possible number given to these two. So your parent chain will be numbered as 1, 2, 3, 4 and 5. So IUPAC name will be your 3-fluoro, as on third position your fluorine functional group is present, and 2-methyl. On second position this substituent is present, and this substituent contain 1 carbon, that's why it will be methyl. And in your parent chain number of carbon presents are 1, 2, 3, 4 and 5. 5 means pent, and this hydrocarbon is your saturated hydrocarbon, so it will be N. So 3-fluoro 2-methyl pentane. Fluoro comes first before methyl because alphabetically F comes before M. Now this is your next example, which is your unsaturated hydrocarbon, which is containing chlorine functional group in it. So this is the number given to your parent chain, as if you start from this position, then 1, 2, 3, 4, chlorine will be positioned as your third carbon as well as your double bond also, and second is less than your third and first is also less than your 3 number. So that's why this is the correct numbering of your parent chain, and IUPAC name will be your 2-fluoro 1-butene, else 2-chloro-but-1-ene. As on second position there is your chlorine functional group and 1, your double bond is present, so that's why IUPAC name is 2-chloro-but-1-ene. Now your next functional group is alcohol. The general representation for this functional group is given by OH. General name will be given as, for basically this general name as I am discussing only for your saturated hydrocarbons, but in our example we will learn also how to name your unsaturated hydrocarbons. So this is your general name, alkanol. This all is used for the IUPAC of alcohol. Now this is the example. This is also your saturated hydrocarbon which is containing alcohol functional group. So basically first, according to the rule, you have to give the lowest possible number to this alcohol functional group. So this is the numbering of your parent chain, 1, 2, 3, and this will be your IUPAC name, propanol. As if your functional group is present on first carbon, so it is not necessary to represent the 1 number on your or in between your IUPAC name, because it is quite justified that if number is not present then it should be present on the first position. So you can also write as propane 1-ol, or you can also name this hydrocarbon as propanol. Now this is your second example in which 2 alcohol functional group is present. So this is the number of your parent chain, 1, 2, 3, 4 and 5. If you also start from this end, the numbering will be same, 1, 2, 3, 4 and 5. So you can start numbering from either direction as you wish. So IUPAC name will be 2,3-pentane diol. As according to the rule, if 2 or more than 1 functional group is present, then you have to add di, tri, tetra as per the number of functional group present in your hydrocarbon. So that's why you have to first identify the position at what number carbon your functional group is present, and you have to write in your IUPAC name until and unless it is present on your first position. So this is your 2,3-pentane diol. So at this stage we have studied how to name your saturated hydrocarbon which contain this alcohol functional group. So my next example is your cyclic unsaturated hydrocarbon which contain this alcohol functional group, and according to this nomenclature you have to write the position at which this double bond is present before the starting of your name, and the position at which this alcohol functional group in between your IUPAC name. So this is the number on your parent chain 1, 2, 3, 4 and 5. Now you can also ask a question, why shouldn't I start from this end or else this end? But according to priority rule, if you go back and see that table, alcohol come first, then your alkene. So you have to give first position to this alcohol functional group rather than giving first position to alkene functional group. So that's why this is the correct representation of your parent chain, and the IUPAC name is 2-pentene 1-ol. So why I wrote this 2 in front of this name? Because of the rule that I taught you previously before starting this example. So 2-pentene means because this double bond is present, 1-ol because this OH is present on your first position. So now at this stage, this alcohol functional group is present. All the rules I have discussed for alcohol functional group. So let us move on your next functional group, which is your ether. Next question that should be arising in your mind is, what is ether? Ether is ROR, in which R is your alkyl side chains, and this is the general representation of this ether functional group, in which oxygen is connected on its both ends by alkyl side chains. One side chain with oxygen is termed as your alkoxy group, while the other side chain without this oxygen is termed as your alkane chain, base chain. So the next question that should be arising in your mind is, which alkyl chain should be connected with oxygen and termed as your alkoxy group? And according to this ether functional group rule said that shorter alkyl chain become alkoxy substituent, means the side chain which has less number of carbon in it will be termed as your alkoxy group, while the side chain which has more number of carbon atoms would be termed as your alkane base. I know it is very difficult or quite difficult to understand, so let us understand this by taking this example, in which oxygen atom is connected with two side chain. One side chain has only one number of carbon, while other side chain has two number of carbon, right? 1 and 2 and 1. Okay, now 1, 2, it means larger or longer alkyl side group. So that would be termed as your alkane base. Alk means number of carbon that is present in your parent chain. It means 1, 2 means eth. So this is your saturated. That's why it will be ethane. While this moiety, as this has only one number of carbon, that would be a shorter alkyl group, and with oxygen it will be termed as your methoxy, and the IUPAC name for this example will be your methoxyethane. Now move to your second example, in which now it is very difficult to understand which should be termed as your shorter alkyl group and which should be termed as your longer alkyl group. Now 1, 2, and this side 1, 2 and 3. So 3 is obviously greater than 2, that's why this will be your longer alkyl group. So 1, 2 and 3, and will be termed as your propane, while this will be your ethoxy, as eth means number of carbon is equal to 2, and with oxygen it will be termed as your ethoxy. So the IUPAC name will be your 2-ethoxy, as in this parent chain at second position this ethoxy group is present, and on the second position itself this methyl substituent is also present. That's why 2-ethoxy 2-methyl propane. Now we have understand, or else you can say you have understood what's the rule behind the nomenclature of the ether functional group. Now we will move to our next functional group, which is aldehyde, and this is the general representation for your aldehyde functional group, in which carbon is connected double bonded with oxygen atom, and on third side it is connected with hydrogen, and on its fourth side it can be connected with alkyl group side chain, or it can be connected with hydrogen also, and the general name for this aldehyde functional group will be alkenyl. As with this general representation, it is quite clear that it has only one side to which it can be connected with any other substituent. So that's why the position allotted to this functional group will always be your first position. So it is not mandatory to clarify the position at which this functional group is present in your IUPAC name. So take this example. According to rule, you have to give the least possible number to this functional group. So the number given to your parent chain will be 1, 2, 3 and 4. As I have told you earlier that the position given to your aldehyde functional group will always be 1, and it is not mandatory to define the position in your IUPAC name. So IUPAC name for this hydrocarbon will be a 3-methyl, as on third position your methyl substituent is present, butane al. At this point we have understood how to name your unsaturated. At this point we have understood how to name saturated hydrocarbons which contain this aldehyde functional group. Let us move to our next example, which contain your double bond, or else you can say unsaturation, as well as this aldehyde functional group also. So according to this priority rule, which I have shown in my first slide, which has functional group definition as well as this priority table, you have to give priority to your aldehyde functional group rather than giving to this double bond. And while choosing your parent chain, you have to select both of this. You have to give the least possible number according to rule to your this functional group, then this. And this is your parent chain, which contain both this aldehyde functional group as well as your double bond, and on third position your double bond is present, and according to rule you have to give this third position before writing your general name for this functional group. Okay, on second and third position your methyl substituent is present, and the number of this methyl substituent is 2, so that's why you have to add di also. So the correct IUPAC name is 2,3-dimethyl-3-butenol. 3 comes before this base name. Okay. At this stage we have understood how to name saturated as well as unsaturated hydrocarbon which contain aldehyde functional groups in it. We will now understand or study how to name cyclic structures which contain this aldehyde functional group. According to rule, you have to remove this al suffix while naming that aldehyde. Rather than adding this al suffix, you have to add carbaldehyde suffix. Okay, so this is the example of your cyclic structure which contain this aldehyde functional group, and this is the number on your parent chain, as this aldehyde functional group should get the least possible number. That's why number has been starting from this end, 1, 2, 3, 4, 5 and 6. Number of carbon in your parent chain is 6. Hence the name given to your parent chain will be cyclohexane. Okay, cyclo because this is a cyclic hydrocarbon and this is saturated, that's why we have to add ane suffix. And according to rule, now you have to add carbaldehyde for this aldehyde functional group, and the correct IUPAC name for this structure is cyclohexane carbaldehyde. Okay, so we have covered the rules for the nomenclature of saturated, unsaturated as well as cyclic hydrocarbon which contain this aldehyde functional group. Now move to your next functional group, which is your ketone. As the basic difference between aldehyde and ketone is that in ketone it is mandatory to connect the carbonyl. Carbonyl means CO. Okay, CO moiety to one hydrogen on one side, and on another side it can be connected to alkyl side chain, or else it can be connected to hydrogen as well. But in ketone it is mandatory that the carbonyl functional group means CO should be connected to two alkyl chain on its both side. Okay, So that is the general representation for this ketone functional group, in which the carbonyl moiety is connected to two side chain, and the general name for this is alkanone. You have to add "-one" suffix while naming ketone containing hydrocarbons. Okay, so this is the first example, in which, or the major difference is also that aldehyde is always present on first position on your parent chain, but this ketone can be present on any position in your parent chain. Okay, so in this example, you have to give the least possible number to your functional group. So you have to start from this end, and this is the number given to your parent chain: 1, 2, 3 and 4. Okay, 4 means but, and A because this is the saturated hydrocarbon, and you have to add "-one" suffix for this, and as this present on your second number carbon, so you also have to add second position while naming this structure, and the correct IUPAC name is 4-butane 4-one. Okay, you have to eliminate this E. Okay, because according to this nomenclature, two vowels cannot come together while naming structures. Okay, now this is the next example, because we have covered rules for the saturated hydrocarbons which contain ketone. Now move to the example which contain unsaturation as well as your ketone functional group. So now the question arises is, from where, or else you can say, at which end you have to start numbering to your parent chain. You can also start from this direction, you can also start from this direction also, and you can also go back and see that table. According to that priority table, you have to give priority to ketone rather than giving to your double bond. Okay, so now the number for your, now you should also raise a question whether I have to start from this end or not, because if I start from this end, consider 1, 2, 3 and 4, this double bond will be missing. No, that's why the second reason why you can't start from this end is you have to add this double bond in your parent chain. This is the necessity of this nomenclature. Okay, you have to add all the functional group in your parent chain as possible. Okay, 1, 2, 3 and 4. This is the number of your on your parent chain: 1, 2, 3 and 4. Okay, on second position your ketone functional group is present, while on third position your double bond is present. So IUPAC name is 3-methyl, because on third position your methyl substituent is present. As in previous slide, I have told you that you have to give number to your double bond before your base name. Okay, so that's why this 3 comes before this name, and 2 you have to add in between your name. Okay, so 3-methyl 3-butene 2-one. Okay, now we have covered the rules for the nomenclature of saturated hydrocarbon as well as unsaturated hydrocarbons which contain this ketone functional group, and this is the example in which 2 means double ketone functional group is present. Okay, so from either direction, if you start numbering your parent chain, the location for your functional group will be same. So you can start from this, or from this end also, and from this end also. So this is the number given to your parent chain: 1, 2, 3, 4 and 5, and on second and fourth position your ketone functional group is present. So the IUPAC name is pentane 2,4-dione. Di because 2 carbonyl or else 2 ketone group is present. Okay, so now we have covered the rules for the nomenclature of your ketone functional group. Now we will move to our next functional group, which is carboxylic acid. Okay, so this is the general representation for this carboxylic acid, in which the carbon is connected to double bonded with one oxygen, and on one side it is connected to hydroxy group. This group is known as hydroxy group. Okay, so this whole moiety is known as your carboxylic acid functional group, and the general name is alkanoic acid. oic acid is the suffix used for the nomenclature of your carboxylic acid. So this is the first example in which your carboxylic acid functional group is present. As from this general representation, it is quite clear that only one side can be filled. So that's why it is always be present on the first position, and according to priority also you have to give the first position to in your parent chain to your carboxylic acid. Okay, so you have to start numbering from this side to your parent chain, and you have to number or select that parent chain that should contain the maximum number of carbon atom in it, because there are two possible way in which you can select your parent chain is this 1, 2, 3 and 4, while 1, 2, 3, 4 and 5. So this is your parent chain because this has more number of carbon than this. So this is the number given to your parent chain 1, 2, 3, 4 and 5, and in first position your carboxylic acid functional group is present. So the correct IUPAC name is 3-methyl because on third position your methyl substituent is present, and number of carbon on your parent chain are 5. So pentane oic acid. Oic acid is suffix used for the carboxylic acid functional group. So next example in which your double bond is present as well as your carboxylic acid functional group is present, and according to priority rule you have to give the least possible number to your carboxylic acid rather than giving to your double bond. So that's why this is the correct order in which you have to start numbering to your parent chain 1, 2, 3 and 4, and on third position your double bond is present, while on first position your carboxylic acid is present, and according to rule you have to write 3 number before your base name. Okay, because you have to give number to your alkene before the starting of your name. 3-butane oic acid, as it is quite obvious that this is carboxylic acid contain first position, so there is no need to write first in front of this suffix. Okay, because carboxylic acid always present on first position. So this is the next example which contain your cyclic structure. Sorry, it's not a chain. So this is the cyclic structure which contain this carboxylic acid, and according to rule you have to give one number to your carboxylic acid, and this is the correct representation given to your cyclic structure 1, 2, 3, 4 and 5. So that's why it will be cyclopentane. And as I told you in your aldehyde functional group, you have to remove that ul suffix, so that in this also you have to remove this oic acid suffix and you have to add carboxylic acid suffix in replacement of this oic acid suffix while naming cyclic structures. Okay, so the correct IUPAC name is cyclopentane carboxylic acid. Now we have covered this carboxylic acid also. We will move to our next functional group, which is ester. There is a basic difference between carboxylic acid and ester is in the hydroxy group, which is this OH. If this is O and this if O is connected to hydrogen, then it will become carboxylic acid. But if you replace that hydrogen with your alkyl side chain, then it will be your ester. So this is the only difference between carboxylic acid and ester. So it has been divided into two parts. This alkyl chain with carbonyl in it is known as your acyl group, while this side chain which is connected to oxygen or else which is a replacement of your hydrogen is your allyl group. Okay, so let us take this example. So this is the side chain which is connected to oxygen, and this is the side chain which is connected to your carbonyl functional group. So 1, 2 and 3. So this will be termed as your acyl group, and this will be termed as your allyl group, which will be methyl, because number of carbon present in this side is 1, so that's why it will be methyl, and the correct IUPAC name is methyl propanoate, as you have to add this O8 suffix while naming this ester. Okay, and you have to add O8 on this acyl group. Okay, always you have to add OIT while naming this acyl group. So this is the next example in which this substituent, as in my previous lecture I told you that this is the third butyl. This is the substituent in which number of carbon is 1, 2, 3 and 4, and this substituent is named as your third butyl, while this is your acyl group, and 1, 2, 3 and 4 in your acyl group also the number of carbon presents are is your 4, and that's why it will be butanoate. This moiety will be your butanoate, while this will be your third butyl. Okay, so third butyl butanoate is the correct IUPAC name for this structure. And this is the next example in which your acyl group is your cyclic structure, while this is your alkyl group in which 1, 2 and 3 number of carbon are present. And in my previous lecture I told you that this substituent is named as your isopropyl, and this is the representation of numbering, because you have to give the least possible number to your ester group, and this is the correct IUPAC name is isopropyl cyclohexane carboxylate. Because carboxylate, why we have added, because while naming cyclic structure you should not write like al suffix, oic suffix and your OH suffix. You have to write some other suffix, as in aldehyde I told you that is carbaldehyde, and in oic carboxylic acid that suffix is carboxylic acid itself, while naming the cyclic structure of your ester you have to add carboxylate. Okay, now we have covered all the rules for the nomenclature of hydrocarbon which contain this ester functional group in it. We will move to our next functional group, which is amide, and and this is the general representation of your simple amide in which the carbonyl functional group is connected with NH2. Okay, and the general name for this amide is alkanamide, and this is the substituted amide in which these hydrogen is also substituted with some other alkyl chain, and the general name will be N-alkyl, means these alkyl chain, this substituent is connected to nitrogen and these are represented as N-alkyl, and the name given for this moiety will be alkanamide. Okay, so this is the first example to understand how to name the hydrocarbon which contain this amide functional group in it. So the parent chain is 1, 2 and 3. So it will be propanamide because this nitrogen is connected with hydrogen itself. So that's why this is in category of simple amide, and the general name will be given as your alkanamide. So alkanamide means number of carbon present in your parent chain is 1, 2, 3. So that's why IUPAC name is propanamide. Or else you can also give number to like 1, 2, 3. This is the wrong way, sorry. You have to write this way 1, 2, 3 because you have to give the least possible number to your functional group. I'm sorry for this mistake. And the next example is your substituted amide, because nitrogen is connected to the alkyl side chain and one it is connected to hydrogen also. So this is in under category of substituted amide, and your parent chain contain 1, 2, 3 number of carbon. So the general name will be N-ethyl because it is connected to ethyl substituent, as this substituent has number of carbon is equal to 2. So it will be N-ethyl propanamide. Okay, so we have covered both substituted amides as well as simple amide nomenclature. Now move to next functional group, which is amine. Okay, so this is the general representation for this amine functional group in which nitrogen, which has 3 valency means it can extend its bond up in 3 ways or else 3 directions. So this nitrogen is connected with 3 alkyl chain or hydrogen. Okay, as a simple formula is ammonia, which is NH3, in which nitrogen is connected with hydrogens. If that hydrogen will be replaced by alkyl chains, that will be your amine functional group. So rule for the nomenclature of this amine is the alkyl group attached to the nitrogen are put in the alphabetically order with no space between the name, and they are followed by the word amine. Okay, if two or more substituents are same, then you have to add di-tri prefix. Okay, so this is the first example in which all the three substituents are different, so you need not to add this di-tri prefix, and you have to write all the substituent in your alphabetically order. So in order to write alphabetically, you also have to recognize the name for all the substituents. So in this substituent, this is your 1, 2, 3. Okay, 3 number of carbons, and it is connected to second position. In my previous lecture, I told you that if propane substituent or else propyl substituent, if it is connected to second position, then it is termed as isopropyl. Okay, and this substituent contain 1, 2 number of carbon. Okay, so it will be termed as your ethyl, and this substituent contain your 1 carbon, so that will be methyl, and on second position this whole functional group is present. So the IUPAC name, or else first of all you have to add this alphabetically order, which is your ethyl, isopropyl, and then methyl. So the IUPAC name is N-ethyl, N-methyl, propane 2-amine, because on second position this functional group is present in this parent chain. Okay, so N-ethyl, N-methyl, because E comes before M according to this alphabetically order, and propane 2-amine, because on second position this amine function group is present. Okay, that's how you have to first recognize the substituent present on this nitrogen atom, and then you have to find your parent chain, and then you have to arrange it in alphabetically order, and last step is to name your IUPAC according to this rule. Okay, this rule. Our last functional group is nitrile, and this is the general representation of nitrile functional group in which carbon is triple bonded with nitrogen, and general name for this functional group is alkane nitrile, because nitrile is the suffix used for the nomenclature of nitrile functional group. So this is the first example in which this nitrile functional group is present. Now you have to find the parent chain first. So this is the parent chain, as you have to give the priority to your functional group rather than giving to your substituent. And you can also ask me a question, like you can also start numbering from here up to here, so that the maximum number of carbon present in your parent chain. No, this is the wrong, because you have to start numbering from that carbon that should have functional group in it. So therefore I have started from this direction, although it contains less number of carbon in it, but you have to give priority to your functional group rather than giving to other things. So this is the correct representation of your parent chain, 1, 2, 3 and 4, and on your second position your ethyl functional group, ethyl substituent is present. So this is the correct IUPAC name for this structure is 2-ethyl butane nitrile. Okay, so this is the cyclic structure in which this nitrile functional group is present. So from here onward you will start numbering to your parent chain, 1, 2, 3 and 4, and on first position your nitrile functional group is present, and the IUPAC name given for this structure is cyclobutane carbonitrile. Okay, rather than adding this nitrile suffix you have to add carbonitrile suffix. Okay, now this is the structure in which rather than adding only nitrile, your bromine is also present. So from here onward you will start numbering your parent chain, 1, 2 and 3, and on second position your bromo is present. So the IUPAC name is 2-bromo-propane nitrile. Okay, so up to now we have covered all the functional group as well as your unsaturated hydrocarbon also. We have discussed all the rules behind the nomenclature of your saturated as well as unsaturated and all the hydrocarbon which contain functional group in it. So at this point we have studied all the rules for the nomenclature. Okay, now we will solve one practice question which will be having all the rules. Okay, so this is the practice question in which now you have to first we have to select your parent chain so that it should not violate your priority rule. Okay, so there are two ways in which you can start numbering your parent chain, in this way also and from left to right also. Okay, so if you start from right, then 1, 2, 3, 4 and 5. Second position will be given to your hydroxy functional group and fourth position will be given to your bromine functional group. While if you start from your left to right, then second position will be given to your bromine functional group and fourth position will be given to your hydroxy functional group. But according to priority table, you have to give priority to your hydroxy functional group rather than giving to your bromine functional group. Okay, as one more thing you also can think of is that if you start from here to here or else from here to here, 1 and 5 is the same number given to your carboxylic acid, so there is no need to worry. The thing you have to worry is about which number you have to give to your hydroxy group or to your bromine functional group. And according to priority, hydroxy comes before bromine. So this is the correct way of numbering your parent chain. You have to prioritize your hydroxy functional group rather than prioritizing this bromine functional group, and the priority rule says that carboxylic acid, then alcohol, then bromide, or else you can say. Okay, so we have chosen in this manner only. So IUPAC name will be 4-bromo 2-hydroxy pentanoic acid. As why I have added this hydroxy? Why shouldn't I have added this? I can also add like this pentane or dioic acid, right? But according to rule, you have to add suffix for only one functional group, and that should be your topmost priority functional group. And in this example, the topmost priority functional group is your carboxylic acid. So you have to add suffix only for your carboxylic acid, and other functional group should be added as your suffix. Okay, sorry, prefix. So bromine and alcohol will be named as your prefix, and oic acid will be added as your suffix. Okay, now carboxylic acid is present twice in this structure, so that's why we have added dioic acid, and P comes before H in your alphabetically manner, so that's why 4-bromo 2-hydroxy pentanoic acid is the correct IUPAC name for this question. Up to here I have covered what is hydrocarbon, versatile nature of carbon, which is in basic concept of hydrocarbons, and all the rules for the nomenclature of saturated hydrocarbon, unsaturated hydrocarbons, and all the hydrocarbon which have functional group entities. So basically what you have to do is practice more and more, because as you know that practice makes the man perfect. If you practice this, IUPAC will be in your mind forever. So my last advice is to practice more and more. If you like my lecture, please like, share, and please subscribe our channel at Catalyst for IIT JEE if you haven't subscribed it yet.